So hi there, wonderful Astroperson. Welcome back to the Astroform channel and thanks for tuning in. In this tutorial video, I'll explain how you can process videos of the planets using Autostakkert3. I did a couple of YouTube live streams in September where I shared my attempts to capture Jupiter and Saturn with my telescope and camera. Now, I had a lot of fun with you guys, thank you for joining these live streams in September, but I didn't show you yet how I process my videos of the planets into a final picture. I've decided to make 2 additional tutorial videos. In this first video, I'll show you how I use a free software program called Autostakkert to create a picture of Jupiter from one of my video captures during the live streams. And I will release a second video next week where I also explain how you can further process the picture we are going to create in this video using another freely available software tool called Resizing. If you want to follow along with this tutorial, you can. I have shared that video of Jupiter and you can find the link to that video in the video description below. But enough talk, let's move over to the desktop computer so I can show you my workflow. So hi folks, welcome to my desktop. Now before starting this tutorial, I just quickly want to mention that I am not necessarily the foremost expert on planetary imaging, and I have been capturing the planets under light polluted skies in the city center in the Netherlands with the planets close to the horizon. So we are not working with the highest quality data either. If anyone wants to add any tips or comments, please feel free to do so in the comment section below this video, because we can all learn from one another. And let's start with this tutorial. So upon opening the program, Autostakkert shows 2 separate windows. The main window on the left shows you all the processing options, and a second frame view window on the right shows you the video you want to process. You can either select a video by dragging and dropping your video on the frame view window, or as an alternative, you can click on the open button on the main processing window and select the video you want to process. Now, either one of those steps will open up the video in the frame view window and it will show you the first frame of that video. As mentioned before, you can find the same video of Jupiter in the link in the video description so you can follow along. You can significantly speed up the processing speed in Autostakkert by decreasing the width and height of the video in the frame view window so that it only encompasses the planet. You can do this by adjusting the width and height sliders in the frame view window or by typing a value next to the sliders in the value box. For this video, let's select a width and height of 800 pixels. In planet mode, the planet will be automatically centered in the frame view window. You can alter this view by holding down the Shift key and left clicking on your mouse while dragging the planet around. This may be useful when you have captured a couple of the Galilean moons of Jupiter that may be off-center. In this video, we unfortunately don't have any extra moons, so we can easily recenter the planet by clicking on Offset in the frame view window. The first action Autostakkert needs to perform is to assess the quality of each of the video frames. But before Autostakkert can actually perform that assessment, it first needs to stabilize the individual frames of your video. When playing your video by clicking on the play button in the frames view window, you'll notice that the planet wobbles a bit. This is partly due to the atmospheric turbulence and possibly also because your mount experienced some tracking error while capturing the video. Autostakkert can adjust for those errors by stabilizing the individual frames of the planet in the video, so let's perform that action first. By default, Planet is selected as an option in the Image Stabilization section of the processing window. In this mode, Autostakkert will automatically detect the threshold that separates the bright pixels of the planet from the dark background. As an extra option, you can select Dynamic Background. This option will automatically determine the background value. Now, I recommend you use this option especially when you captured videos with a varying brightness of the background. This can for instance be the case when you've captured some videos of the planets during twilight. The other option for image stabilization is the surface option. This option should be used to process close-up videos of the moon or the sun. I will show you how to process a video of the lunar surface in a future video, so if you want to follow that tutorial as well, you're welcome to subscribe to the channel. The quality estimator in the processing window is automatically set to Laplace in Autostakkert3, with the option to set a noise robust value. The smallest noise robust setting of 2 will analyze a very small 2x2 area of the frame, whereas the maximum value of 8 will analyze a much larger area. The smallest 2 setting is best used when you have exceptionally good seeing conditions and a very high signal to noise ratio picture, meaning that your planet stays in position, it doesn't wobble around across the frames of your video, and you can see lots of surface details. Now obviously this is not the case in our video, we definitely have some mediocre seeing conditions and the planet frames are quite noisy. I will therefore leave the noise robust setting at the default setting of 4, which works well for most videos. Note that the quality estimator is set to local, with the option to switch to global. The best results are often achieved by using the local estimator. Autostakkert will then select the best areas of each alignment point for every frame in the video, whereas global will assess the quality of every frame as a whole. So I will select local. In order to be able to use alignment points, we first have to set up these alignment points in the frame view window. So let's do that first. By setting up alignment points across different areas of the planet, you can define regions of the planet that Autostakkert will track to compensate for seeing distortions. For example, when playing the video in the frame view window, you'll notice that the planet wobbles around quite a bit, so the planet features will change position in every frame. As this wobbling differs not only between frames but also within frames across different areas of the planet, it is wise to set alignment points. Autostakkert will try to analyze the changing position of the features for every alignment point in every frame and will try to put them back into the same positions across frames to compensate for the seeing distortions. Ideally, you should end up with a stacked picture of the planet as it would be without any seeing distortions. So one major question here is how many alignment points you should use and where you should place them, so let's discuss this. First of all, if you don't want to go through the effort of manually adding alignment points, Autostakkert produces quite good results when using the Place AP Grid option in the frame view window. You can determine the size of the alignment point squares to be 16 pixels or higher by using the up and down arrows in the frame view window or by scrolling your mouse wheel. Depending on the size of the planet in your video, you want to experiment with which AP size works best. Smaller alignment points work very well when seeing conditions are good and you can see sharp surface features in your frames, while larger alignment points work better when features of the planet are blurry due to poor seeing conditions. In this particular video, we have mediocre seeing conditions and a rather blurry picture of the planet. So in this case, a good option would be to use an alignment point size of 64, which can cover larger areas to detect different features and contrasts. If you're unsure about which size would work best, a good option is to use the multi-scale option. When selecting this option, Autostakkert will create a 3-dimensional AP grid with larger AP squares placed on top of smaller APs. When a smaller alignment point doesn't provide enough information, Autostakkert will use the information of the larger AP on top of the smaller one, as well as information from the adjacent alignment points to determine the best position for that particular area. A final thing to check is the minimum brightness setting in the frame view window. You don't want alignment points to be too close to the edge of the planet. If that is the case, Autostakkert will have issues in determining the correct position of the edge of the planet when the majority of the alignment point area covers the black background rather than the planet. So by increasing the minimum brightness in the frame view window, you'll notice that the alignment points will be placed more towards the inside of the planet. For this particular video, let's set the alignment point size to 64 pixels with multi-scale checked on and a minimum brightness of 50. When clicking on Place AP Grid, you'll notice that this produces a nice grid of smaller and larger alignment points that primarily cover the planet. Unfortunately, it is hard to completely automate the alignment point process. Planetary imagers, including Emil Krijkamp, who is the developer of Autostakkert, have indicated that manually placing alignment points can often result in a higher quality stacked image of the planet as compared to using the automatic AP Grid option. You can easily add alignment points by left clicking on the frame of the video. Now, if you're unhappy about the size of the alignment point, you can adjust the size by using your mouse wheel or by clicking on the up and down arrows in the frame view window to increase or decrease the size of your alignment point. There are a couple of tips you should take into account when manually adding alignment points. First, as already said before, we should avoid placing alignment points too close to the edge of the planet. So in this video, let's place some 56 pixel sized alignment points towards the edges of the planet. These alignment points close to the edge of the planet should mainly cover the planet itself and not also the black background. Second of all, it is best to place alignment points in high contrast areas, such as around the shadow of a moon on Jupiter. Now, we don't have such contrast-rich areas in this video, unfortunately, but it is a good idea to place some smaller alignment points on the edges of the main cloud bands across the surface of Jupiter. So let's place some 56 sized alignment points across the surface of Jupiter, where the darker cloud bands of Jupiter are meeting the lighter areas. Remember that alignment points should always have sufficient overlap, so that if one alignment point doesn't provide enough information, the information of the adjacent alignment points can be used. Finally, it is also recommended to add alignment points so that they cover the entire surface of the planet. So let's place some larger 104 sized alignment points on top of the smaller ones to make sure every part of the planet is covered. After placing the alignment points, it's time to press the Analyze button. Autostakkert will now assess the quality of every alignment point in every frame of the video. When the image analysis is completed, the label of the frame slider turns green and the frame view window shows all frames sorted by their quality, from best in the beginning of the video to worst at the end of the video. The main processing window will also show a quality graph indicating the frame quality over time and the distribution of the sorted frames in a green line. This green line is rescaled so that the best frame is always set to 100% on the top left and the worst quality frame is always set to 0% on the bottom right. For this particular video, Autostakkert shows a rather linear decrease in quality from the best frame on the top left to the lowest quality frame on the bottom right. Also note that the frame view window also shows a quality value for each of the frames in the video. So in my case, the best quality frame has a value of around 278 and this value goes down when moving the slider to the right for the lower quality frames. Now that the quality assessment is done, it is time to stack your frames. One very nice feature in Autostakkert is that it can create multiple stacked images from one video using a different number of frames and or different percentages. You can use the boxes in the stack options in the top right column of the main processing window to either put a value in for the number of frames to stack or a percentage of frames you want to stack. You can put values in each of the 4 boxes in the number of frames and percentages of frames options. When you fill out multiple options, Autostakkert will create multiple stacked pictures of the planet. The first major question is how many frames we should stack. Now, one general rule of thumb that usually works well is to stack about 50% of your highest quality frames, especially when the quality of your frames are similar across the video. However, when there is a lot of variation in quality between the frames in the video, it may be better to select a smaller percentage. For instance, when comparing the quality of the frames in this particular video, you'll notice that there are only minor differences between the highest quality frame in my video with a value of about 278 and the lowest quality frame, which is around 254. So all pictures have about the same quality. With such small differences in quality between the frames, you may be better off stacking a high number of frames, as more frames will provide more input to create a higher quality stacked picture of the planet. Also, using a higher number of frames usually provides a stacked image that can be better processed using other software like Resizing, as compared to using only a small number of high quality frames. It is also good practice to experiment a bit, so let's create stacks of the best 95%, the best 50% and the best 25% of the frames in this video. Before clicking on the stack button, note that there are different options to create a reference frame. Now the term reference frame doesn't quite cover that what Autostakkert does. Autostakkert will not select just one frame as a reference frame, but instead it will create a stack picture from a larger number of best quality frames in your video. For example, when selecting auto size, quality based, Autostakkert will select and stack about 50% of your highest quality frames to create a reference stack to which all the frames are aligned and stacked. This default option works quite well in most cases, but if you want to determine the number of frames for the reference stack yourself, there is an option to switch off auto size and use the slider to select the number of highest quality frames you would like to use as a reference. For this tutorial, we will select auto size. There is a second option to check double stack reference. When choosing this option, Autostakkert will create two reference stacks instead of one, where the first stack serves as input to create a second stack, which should create a higher quality reference stack. The process will take more time, but as it may lead to a higher quality reference stack, we'll select double stack reference as well. There are also a number of options in the right column of the main processing windows we need to discuss. The first option is named Normalize Stack. We will check this option as it will set the brightness of the image to a fixed percentage, and as such it will compensate for the brighter than normal backgrounds. Next, Autostakkert offers a Sharpened option. When selecting this option, Autostakkert will produce a second, sharpened stacked image of the planet. When checked on, you can also decide to blend in a percentage of raw images, which may increase the sharpness of this stacked picture. In this tutorial we will not select the sharpened option, as we will use Resizing to further sharpen our stacked image created by Autostakkert in a second tutorial. Next, RGB Align will align the red, blue and green channels after stacking the image, creating a good color balanced picture of the planet, so we will select that option as well. There is also an option to select Save in Folders. This is useful when you have requested more than one stacked image in the stack option boxes. Autostakkert will then create separate folders for each of the stacked pictures, so we will select that option as well. Finally, Autostakkert3 has two advanced settings options, Resample and Drizzle. Resample will simply provide an enlarged picture of the planet without increasing the resolution of your picture, so we will not use that option. Drizzle, however, is a more sophisticated option you might want to consider, especially when you have undersampled data. A lot of folks end up with rather small images of the planets as they are very tiny objects in the night sky. Drizzle in Autostakkert relies on small movements in your recordings to fill in the missing information between pixels across frames, and this can help you to produce a higher resolution final picture of the planet. As my video is probably more oversampled at 0.1 arcsecond per pixel rather than undersampled, I will not select the drizzle option for this video. As a rule of thumb, planets are best captured with about 0.1 arcseconds to about 0.25 arcseconds per pixel. If you have captured the planets at a higher arcsecond per pixel, it is wise to experiment with drizzle. For this video, we simply select advanced settings to off. Now we are finally ready to hit that stack button and look at our results. Let me show you the resulting stacked pictures of Jupiter when using 25%, 50% and 95% of the video frames. In this case, there's not a whole lot of difference between the pictures. The 25% stacked picture looks a bit sharper as compared to the 50 and the 95% stacked pictures, but the differences are pretty small. This was to be expected, as the quality of the best frames was only slightly better than the quality of the worst frames in this 1-minute video of Jupiter. In this case, I will select the 95% stacked picture of Jupiter for further processing, as it includes a higher number of frames, and this really makes processing in other software programs like Resizing easier. In a second tutorial, we will use the 95% stacked image of Jupiter for further processing in Resizing. So I really hope you liked this video. If you did, please consider giving this video a thumbs up and please consider subscribing to the channel. I release a second video of this tutorial in a couple of days where I also discuss how to process this stacked picture of Jupiter further using a program called Resizing. If it's already released, you should find a link to that second part of the tutorial in the video description below. Thanks for watching and clear skies!